Hi guys, good morning. I'll quickly skip the intro and all that stuff. You can see in the below description. Let's quickly jump to the question. It says split the array to make Coprime products. It was very interesting question. I saw in today's contest, the people were not able to do question 3, but they were able to do question 4. When I say it was marked as medium, but it was quite hard, but not that hard. You will see. It says that we are given a zero index integer array called as nums. Cool. We are to split at the index I, which means that okay, I is from 0 to n minus 2 is valid if the product of the first I plus 1 elements and the product of the remaining elements are coprime. I'll show by example. If this is a particular array, I split at this particular index I. So you can see the product of the blue elements and the product of the green elements, they need to be coprime. And when I say coprime, which means that the product, let's say it is A, the product is in total B. So A and B are coprime. And A and B are coprime, it means that they have no common prime factor, which means that they don't have any factor, or their GCD is what, 1. It is also said the same thing that what does co-prime number mean, which means that they don't have any common prime factor, which, like, let's say any number, let's say you take 15 and 8, its prime factors are 3 and 5, its prime factors are 2, 2 and 2. So if I say only prime factors, unique prime factors, it is just 2, it is just 3 and 5, as they are not same, or like none of them coincide, so they are co-prime to each other. Let's quickly see this example. The example was super perfect to understand the entire problem. Let's see the example 4, 7, 8, 15, 3 and 5. So as I said that, right, initially in the beginning itself we got to know, okay, the numbers are co-prime or not co-prime, which means that I just need to look at the numbers and see only the prime factors of the numbers, because only the prime factors will help me find out, okay, if the numbers is actually a co-prime, prime or not. So as the question itself says that, okay, he's just interested in the co-prime numbers, and co-prime means they don't have a common prime factor. So I just find the prime factor, which is unique for every number. So basically for 2, the unique prime factor are 2. I should say the prime factors are 2 into 2, but the unique one is only 2. I just find out that, okay, for 7 it's 7, for 8 it's 2, for 15 it's 3 and 5, for 3 it's 3, for 5 is 5. I just showed you right now, like it's just nothing new, or we are just walking through, okay, it's just a question right now. Cool. Now let's see. As it said that, okay, we need to go to the smallest index I, which means that from left to right, let's say I am iterating and I am breaking, because I have to break the wall at some place, right? So let's start from breaking at the most starting place. Let's say at this place. So if I break here, so it will become like, and I'm now breaking when I write here, I just write the prime factors, because I'm not interested in the numbers anymore. I'm just interested in the prime factors now, because only the prime factors will help me find out, okay, if the block 1 and the block 2 are they co-prime or not, right? So I just put my block 1 here and my block 2 here, right? Cool. You can easily see that 2 is in both of them, which means that a 2 will be a common factor when we do a co-prime of both of them, or basically a GCD of both of them. So these two are not co-prime, because a 2 have a because we can easily see that 2 is in both of them. Let's say if we split right here, then a 2 is 7 and hold this thing here, again 2 is a common. It's not. If we split at this particular index I equal to 2, then what will happen is we will have this and we will have this. You can easily see, oh, interesting, there are no common prime factors. Nice. So my smallest index at which I'm able to find, okay, these two groups is nothing but I equal to 2. So I can return the answer as my particular index, and I'm good to go. And I don't need to iterate on the next, maybe this or this, because I have already found. Now you can easily see how I found, because a 2 is 7, 2, it does not include a 3 or a 5, because here 3 and 5, and a 3 5 3 7, it does not include a 2 7 2 or a 2 and a 7. Now let's see another example. And yeah, before going to the next example, one thing which I missed, and like it was a big thing while doing the contest, I just missed this one. See, n is constrained as from 1 to 1e4, right? Which means that n can be 1, and which means that it can have one element. And you can easily see that we initially showed what is the constraint. It is 0 to I is from 0 to n minus 2. Here n minus 2 will be what? Minus 1. From I is from 0 to minus 1. So whenever my n is 1, it will always return my answer as what? Minus 1. So please put that condition 3 ahead. I was frustrated why it is not coming up. So yeah, it is it. Now let's see this one, example 2. It will help us to visualize the actual algorithm which we will use. So if we have this 4, 7, 15, 8, 3 and 5, again, we just write the prime factors here. Whatsoever unique prime factors those numbers have. Okay. Now we try to split at I equal to 0. We get a 2 and this particular thing, but 2 is common. So it's not the case. We tried at I equal to 1. We get this and this particular thing. Now 2 is also common. Okay, it's also not the case. We check it at I equal to 2. We place this and this. Oh, here 2, 3, 5 all are common. Oh, it's also not the case. I equal to 3. Here also 3 and 5 are common. That's also not the case. I equals to 4. Here also 5 is common. I is not equal to 4 equal to the case. So basically it's just it's finished now because I can't just go ahead. It said nah, I is from 0 to n minus 2. I can't go ahead. So there is no possible answers found. So the answer will be nothing but minus 1 returned. Now you saw one thing right here. I was just moving ahead for every number, which means that if it is example 1 and it is example 2. So basically when I was at 4, it means the prime factor was 2. So ultimately in my back of the mind I was looking for, okay, because ultimately see if it is 2, so I need to place my bar, which is my bar, at some place which after that a 2 is not coming, which means that I cannot place my bar here because after that a 2 will come. So I will try to place my bar next to a location where the final 2 has come. So the final 2 has come here. I will try to place my bar here. Right, cool. Here, but what would have happened if this 7 would also have come, maybe some ahead? So I have to shift my bar again to that location, but luckily my 7 has not come, so I can safely place my left bar because of my left locations, which means because of my left numbers I can place my left bar at this particular location, because a 2, it demands a location where no 2 comes after it. So I just find, okay, what's the location which has the final 2, and after that I place my bar. I place my bar here, which is the left cap. I'm saying for this 5, I'm saying, okay, what I need to place my right bar at a location such that the 5 should not come after it, which means that what is the last location of 5, I'll try to place my bar after it. Last location of 5, here it is. I'll try to place my bar after it, which is my right cap. But whatsoever elements in between this range, I also need to make sure that, okay, all they should follow this particular thing. So the 3 in here, we see, okay, what's the last location it is offering? Okay, this, okay, I'll place my right bar here. You easily saw, right? My left and right are here. So my left cap is here, my right cap is here. It's not overlapping, which means I'm safe. Okay, now let's see example 2, how we can actually visualize that thing. So if we see example 2, if we had this 2, so I need to think in the back of my mind, okay, what's the final 2? Because after my final 2, I need to put my left bar. So my left bar I will put at my final 2, okay, 2. Okay, I'll try to place here. No worries, I'll try to place my left bar here. Okay, no worries. I'll look for, because now it is the range which I need to look for. Okay, every element in this range should follow this condition now. Cool. What will happen is, I'll try to look at 7. Oh, is it 7? No, I'm good, I'm safe. My left bar is safe. my 3. Okay, I'll just go and look. Oh, my 3 is here. My last location of 3 is here. So I need to shift my left bar, because see, every element in this range, earlier my left bar was here, so every element in this range I need to check. So I was just viewing this element and I saw, oh, it's beyond my left bar, so I need to shift my left bar now. My left bar is here right now. Cool, no worries. Now I see a 5. Oh, okay, its last location is beyond that. Okay, I need to put my left bar here. I'll just look at 2. Okay, no location after it. I'll look at 3. Okay, no location after it. I'll look at 5. No location. So basically my left bar or my left cap is right here. Cool, fine. But as in case, we also saw, okay, what will the right bar, which means the right cap. I'm looking forward. Okay, my 5. I look for, okay, what's the maximum location it can go? Okay, this 15. Okay, so my right bar is here. I'm good. For this next 3, now I have to see, okay, for all the elements up till this right bar, because it's the condition, right? Every element should satisfy until this range. I look for 3. Okay, what's the oh, 3. My left bar is safe. Good. 8. Its factor is 2, so I need to look for any location which has 2. Okay, it should be less. My left bar should be, my right bar should be less than that. So I look for 2. Oh, it's beyond my right bar. I need to shift my right bar. I shift my right bar. I go on 3 and 5, not found. Okay, good. My right bar is safe. My 7, not found. My right bar is safe. My 2, not found. My right bar is safe. Oh, my right bar is right here. My left bar is right here. It overlapped quite a lot. Even if they would have overlapped, it's also still not possible, because we just want non-overlapping, right? You understood, right? We want non-overlapping. It's like nothing should come common. Nothing should come common. But here, if they overlap, so it will come common for sure. It's the case that it was -1. Now you saw one thing, right? What happened? I was just trying to shift my left bar or left cap rightwards, and I just trying to, okay, what's the minimum location possible for this left cap? Okay, it's the safest location right here. For this left cap, it was the safest location. So I'm trying to place my left cap very slightly to the safest location possible. And how to find that safest location? By that prime number, anywhere if it is occurring, anywhere if this prime number is occurring, I need to place my left bar after that prime number. Anywhere this prime number is occurring, I need to place my right bar after that number. With this help of prime number, I'm saying, okay, what is this last location? I need to place my right bar after that. Okay, for starting, I'm saying, okay, what's the last location of my prime number which I'm viewing right now? It's after that. Okay, so I need to place it after my last prime location number. Now, okay, it's good. It's very fine that how we will do here in the code which I will show you in the last. It's the code to get to the extreme this particular left bar. So basically, my max go right is the left cap, and my max go left is the right cap. So basically, I'm trying to see, okay, how maximum it will go to the left. How maximum it will go. So it's the left cap and it's the right cap. Here in this, I just find the prime factors of every number at the ith index. At the ith index, if I'm standing at the ith index, which is I'm standing at 4. So I find the unique prime factors of this number, which is 2. So here, this prime factor vector will store all the prime factors for that particular number at the index I. Cool. I'll iterate on every of these prime factor at that particular index I and see what is the maximum location it is bound to go. What is the maximum go right for that particular prime factor. And this MPR of E is a map of right, extreme right of that particular prime factor, which means the maximum right location of that prime factor of the ith element. Which means if it is 2, if the element is 2, which means the prime factor here it is 2, the element is, let's say, 4, the prime factor will be 2. So MPR will be map of right, which means the maximum right which my 2 has gone in this whole array. And with this help, I can get a maximum right, which means my left bar I can get. And with this code, same code, exactly same code, I can get. It's just that, okay, I just iterating from the left, so it's just, sorry, from iterating from the right, so it's just the opposite, but exactly the same. It's just that I will get a right cap. Okay, if I'm good with this, now you will ask, okay, Aryan, now see, half of you would have got the problem and it's good, and now you should solve. But the other half, who are still confused on how to find the prime factor of any number, for them, I will show you guys. So basically, now our task is just very simple and short. I need to find the prime factor of the number. Now I just split my task to very small tasks, which means if this number is 15, so if Aryan, you will give me this 3 and 5, I'll solve this question. You will say right now this. Say right now. If not, then go watch the previous part again. But if you say this right now, then I'll show you, okay, how you will get the 3 and the 5 out of this 15. Which means if the number would have been 8, I will show you how you will get a 2. Which means a prime factor of that number. Now let's see. So basically, we have this number n, and we want to get the prime factor of this number. What are prime factors is there? So although there is a standard algorithm, but I will just show you the intuition behind that, okay, how you will get that. So basically, if we want to say, okay, I will just start iterating. One way is to get it as 1, 2, 3 up till n. Try for every number. Okay, if this is the prime factor of this number, if this is as so on, up till n maybe. But you can just optimize it, because you just don't want to go to up till n. You can go up till root n. I'll show why. Firstly, 1 is never a prime factor, so just forget it. Now as we go on 2, so what we'll try to do is, if I am at 2, I'll try to divide my particular number. For example, I took the maximum number, although the things you will see below might not match the maximum number thing, but I just took, for example, okay, it's the maximum number, so the limit will be, let's say, 1000, because I took the square root of n. I'll show why I took that. One way is that we can go up till 1 to n. One way is we can go up till square root of n. I'll show why. So basically, if it divides, basically I'm standing at 2 and I'm checking, okay, if my n is divisible by 2. If it is, so firstly, if it is, then it's my prime factor. And as it's my prime factor, so I will divide my n by 2 as much as possible. Which means that if my n is 100 and I am standing at 2 right now, so and it is my 100 mod 2 is 0. So my 100 has a prime factor which is 2. Good. But now I have to remove all the prime factors, all the factors of 2 from this 100, because ultimately I don't want again to count a 2 factor again, right? So I'll just do a 100 by 2, which is 50. Still it has a prime factor of 2. I'll just do a 25. Now I don't have. So now, which means that, which means that I'll just try to remove every prime. If I got a prime factor, let's say in this example 2, I'll just try to remove 2 out of this whole number entirely, which means entirely. Cool. Now we'll just go on iterating. With this help, what will happen is, now 4 will never come, now 6 will never come, as such example, right? So basically the numbers would not come, only the prime factors would come. Now you will say, okay, Aryan, it's good, it seems good, but why you just did that 1000 thing and why not up till the whole n? So it's just very simple is that if this for loop, basically it's the code to get the prime factors, right? So what I'm doing is I'm iterating on my number from 2 up till square root of n. Here my n is maximum 1 is 6, so I just hard coded as 1000, right? Now here I just checked, okay, if that number n is divisible by my number, where for example here it was 2 and the example I showed you it was 100, my n was 100 and my I was 2, so is it is, if it is yes, then it's a prime factor, so I will push it in my result array vector, and I'll try to completely remove 2 factor from that 100, which means that until unless my 100 or that particular number n is divisible by I, I'll just remove I, keep on removing I. N equals to n by I, right? And when it is done, if my n is still remaining, it means it's a prime factor, which means that it's a prime factor which is larger than 1000, and any number larger than 1000 which is remaining would be for sure a prime factor. I'll show you why it is the case. Let's say anything happens and this number remains So let's say n is remaining right now. If my n is remaining, let's say it is the number which is more than 1000, right? For sure, you know one thing. If my n is remaining, so for sure it will be more than 1000, because I have been iterating up till this whole thing, right? So it's more than 1000. Now, if it is more than 1000, so any number which should be multiplied with that, it should be something less than 1000, and less than 1000 had all the factors you had already used from 2 to 1000. So if this number, it would have been dividing by any number less than 1000, so it would have already been divided by less than 1000, but it is not. So it should be dividing, it should be divisible by a number more than 1000. But how can a number be divisible by more than its own number? So if it is not divisible by less than 1000, which means less than this number, if it is not divisible by more than that number, which is for sure never true, so it's the case that that number is a prime number, because it's not divisible by less than square root of n, and for sure a number cannot be divisible by more than that number, so it's for sure a prime number. For example, here if we take the example of 15, square root of 15 is 4, so I just move on iterating my loop from 2, 3, 4. Now what will happen is, when I'm starting at 2, okay, it's not divisible, so it's not here, so 4 will also not be here, but 3 is there, so I divide. Now 5 is remaining, loop is completed, but 5 is still remaining, right? You can easily see that 5 is more than square root of n, which is 5 is more than 4, and the next number, it would be less than square root of n. It would be less than square root of n, and as this number 5 was not divisible by any number less than square root of n, which means that any number smaller than square root of n was not able to divide 5, so any number more than square root of n would also not be able to divide 5. Thus, it's a prime number. Now, it's the whole code which I showed you for getting the prime factors. Now, it's just that I showed you in the beginning. It's if n is 1, you need to return -1. It's a big blunder which I did. So yeah, just a heads up. Now, MPR is just the mapping extreme right index of a prime number. I showed you in the above code also, right? It's just the mapping of the extreme right index of a prime number, and MPL is mapping of left. It's the mapping of left index of a prime number, which means if I say 2, my MPR will say, okay, what's the extreme right location of 2? My MPL will say, okay, what's the extreme left location of 2? It's just that. And vector of this another map of integer to vector is nothing but my index to the prime factor, because I don't want to find prime factors again and again. So I just say, okay, for this particular index, all these prime factors are here. For this index, all these prime factors are here. Now here I just marked, okay, for every element, what is my MPL and what is my MPR. Here I just simply hit this. Hits the left cap, it's the right cap I showed you above, and ultimately I just checked, okay, my max go left, which is my left cap, my max go left, which is my right cap, it's my right cap, it's my left cap. If my right cap is less than or equal to my left cap, which means, okay, it's not possible. If it is not, then I just return the left cap index, because see, left cap was max go right, so it's just the left index. I hope that you guys liked it. If yes, then do hit the like button. It motivates me a lot. And yeah, see you guys in the next video. Until then, goodbye. Take care.